Hey everyone, Note 6.5 are on investigating models of sinusoidal functions. So let's take a look at the first example that we have here. A nail located on the circumference of a water wheel is moving as the current pushes on the wheel. The height of the nail in terms of time can be modeled by the graph shown. Find the equation of the sinusoidal function from its graph. So don't forget, you guys, that for a sinusoidal function, the equation after we do all of our transformations is going to be y equals a times sine of k times x minus d plus c, or y equals a times the cosine of k times x minus d plus c. Okay, either way, either equation is perfectly acceptable because they're pretty much the same thing, except they have a phase shift between sine and cosine. So there are several things that we need to know in order to find the equation of a sinusoidal function. We need to know the amplitude. We need to know the equation of the axis. Okay, and by the way, remember the amplitude is going to give us the a value. The equation of the axis is going to give us the c value. Okay, we need to know the period, which will help us to get the k value, okay? And we also need to know the phase shift, okay? So let's find the axis and the amplitude first. So remember, to find the axis, it's always going to be the halfway mark. And to find the axis, all we have to do is the min plus the max, and then divide that by 2. So the minimum right here is -1, the maximum is 3, so I'm going to do -1 plus 3, divide that by 2, and I end up getting 2 over 2, or just 1. So the equation of the axis is y equals 1, okay? And then if I were to graph that out right here, we can see, oh, that definitely looks like it appears to be halfway between the min and the max, okay? All right, so next thing I want to do is find the amplitude. And remember, the amplitude is just the distance right here between the axis and the maximum. So it appears like the amplitude is 2. And then this same thing right here, it also appears like the amplitude is also 2. Okay, so we know that a is 2, but let's just do it by doing the max minus the min. Divide that by 2. So I'm going to take the max, which is 3, subtract the min, so I'm going to do minus -1 or plus 1, divide that by 2, so I get 4 divided by 2, which is 2. So our amplitude, we've confirmed, is definitely going to be 2. Now, the period, I want to figure out the period right here by seeing how long it takes to complete one full cycle. So it appears that it starts at its max, and then it goes all the way back down to its min, and then comes back up to its max in 10 seconds. So our period is 10 seconds. Now our period is going to help us to find the k value. And remember, our period is always 360 divided by the absolute value of k. So I'm going to multiply both sides by the absolute value of k, okay, and then I'm going to divide both sides by p. So that means that the absolute value of k is equal to 360 divided by p. So it's 360 divided by 10, so we know that it's going to be 36. Okay, and then lastly, we want to see if there's any phase shifts. Well, before I see if there's any phase shifts at all, I need to figure out, am I going to use a sine function or a cosine function? Either one is perfectly acceptable. But what I want to do is I want to have it as simple as possible. So if you notice, it starts at its maximum, and then it goes back down and then goes back up to its maximum. And when we have our sine and our cosine functions, remember, sine starts at the halfway point, and cosine is the one that starts at the maximum. Okay, so I think it would make more sense for us to use cosine. And because it started at the maximum exactly, there is no phase shift. Okay, so again, let's go back and revisit our information that we have here. So we know that y equals 1, that's the equation of our axis, but that's also going to be the c value. Okay, we know our amplitude is 2, so that's going to be the a value. We know that k is 36. So we have all the information that we need. We decided to use cosine. So that means that the equation of my graph will have to be y equals, a is 2, times the cosine of k, which is 36, x, and I don't need to include a phase shift because there is no phase shift, plus the c value, which is 1. So this right here would be my equation. And I want to verify that this is correct using Desmos. So if you guys notice, the graph has x values from 0 to 30. So before I do anything at all, I want to change my x-axis so I can see it from 0 to 30. And then the y values are from -1 to +3. And I'll just do -1.5 to +3.5 so I can just see a little bit more of my graph. I have a little bit of space on the top and the bottom, and we need to be in degrees in order for this to work. So then I'm going to go ahead and write in the equation that we got. So we got y equals 2 cosine of 36x plus 1. So if you notice right here, this is our graph exactly how we see it on our paper. So it looks like it's a correct graph. Let's say instead I decided to use sine instead of cosine. So if you notice right here, sine always starts at the midway point at the axis, and it starts increasing. So this is where our sine curve would start right here, which means that it has a phase shift of 7.5 to the right. So I can also say that an equation would be 2 times the cosine of 36 times x minus 7.5 in brackets plus 1. Okay, so let's go, sorry, I didn't mean to say cosine, I meant to say sine. Okay, so let's go ahead and graph this out and see if it ends up falling in the same section. So I'm going to say y equals 2 times the sine of 36 times x minus 7.5 plus 1. And it falls right on top of it, so that is an equivalent answer. Don't forget that we can have infinite possible answers here, okay? So let's go ahead and take a look at the next example. A sinusoidal function has an amplitude of 2 units, a period of 180 degrees, and a maximum at 0,3. Represent the function with an equation in 2 different ways. So I just want to draw a really quick sketch of it so I can see what's happening here. So first of all, it has a period of 180 degrees. So right here, I know that in 180 degrees, it's going to complete one full cycle. And I know that it has an amplitude of 2 units with a maximum at 3, at 0,3. So I know right here that this point here is going to be my maximum. And since it has an amplitude of 2 units, the axis will be 2 units below my maximum right here, okay? Which means that my minimum is going to be 2 units below that. So I'm going to represent my max and my minimum using dotted lines. So here's my maximum right here. And then my minimum is going to be 2 units below that. So it'll be at -1. And it completes a full cycle in 180 degrees. So that means if it starts at its max, it's going to finish at its max, which means it's going to reach its minimum halfway at 90 degrees. And then it's going to reach the axis at 45 degrees, because that's a quarter of the way. And then it will reach the axis again at 135 degrees, because again, that's a quarter of the way. So this is a rough sketch of what my graph should end up looking like. Okay, and we'll label this 3, 1, and -1. So if we know right here that the A is 2, we know that the period is 180 degrees. And remember, if the period is 360 divided by the absolute value of k, then the absolute value of k is equal to the period, 360 divided by the period, which is 180 degrees. So our k value is 2, okay? And then we also figured out that our axis equation is going to be at 1, so that means that c is 1, okay? Now, our first equation that we're going to write is going to be, let's try the simplest equation that we can possibly write. And the simplest equation would be cosine, because cosine starts at its max and then it decreases and then it increases again. So this is the simplest equation because we're looking at it without a phase shift. So my equation would say y equals, we know a is 2, times the cosine of, we know k is also 2x, there's no phase shift, so I don't need to include anything there, plus 1. Okay, that's one possible equation. A second possible equation is using sine. And remember, sine starts at the midway point and then it increases right here. So this right here would be sine starting its cycle right here at 135 degrees, which means it has a phase shift of 135 degrees. So this equation, this possible equation would be y equals 2 sine of 2, and then in brackets x minus 135, because it has a phase shift of 135 degrees to the right, plus 1. Okay? I could have also started it instead at negative 45, because this right here would give me one full sine curve. So another possible equation, I know it said to do it 2 different ways, but I just want to show you a couple more ways. Another possible way is to say that it has a phase shift of 45 degrees to the left. Okay, and then one last option that I want to talk about, but again, there's infinite options, is to start it at the halfway point still, but if you notice, this time it's going down instead of going up, which means it's a reflection of the sine graph. So our last possibility is going to be a reflection, which means that the a value becomes negative. So it would be negative 2 times the sine of 2, and then in brackets, x. Now this has a phase shift of 45 degrees to the right, so we're going to say minus 45 plus 1. Okay, and I'm going to verify all of this on Desmos right now. So when we're verifying this on Desmos, we know our min is negative 1 and our max is 3. And we know that a full cycle will be completed in 180 degrees. So in my chart, or sorry, excuse me, in my settings right here, I want to go from negative 180 to positive 180 so I can see a full cycle, or at least one full cycle. Definitely here we'll see 2 because a period is 180 degrees. And since the minimum is negative 1 and the max is 3.5, I think keeping our y-axis like this is totally fine. So then let's go ahead and type in the equation that we ended up getting, which is y equals 2 cosine of 2x plus 1. So this is the graph that we got. So let's just verify that it's right. It does have its maximum at 0.3. It does complete a full cycle in 180 degrees. And I'm actually going to change the step to 45 degrees so I can see that 180 a little bit more easily, okay? And also because 45 degrees breaks up our graph into our quarters, okay? And it has, I believe that's all I was looking for, right? It has an amplitude of 2 units, okay? So now let's check to see how the rest is. So y equals 2 sine of 2 times x minus 135 plus 1. Same exact graph. Okay, let's check the next one. Y equals 2 sine times 2, 2 sine of 2 times x plus 45. So it's shifting to the left 45 degrees plus 1, and it still works. Or y equals negative 2 sine 2 times x minus 45 plus 1, and it still works. So all of these are possible examples, are possible equations for the graph. Again, we have infinite options, okay? All right, the last thing that we have is this example right here where it talks about the moon, and it says the moon is always half illuminated by the sun. How much of the moon we see depends on where it is in its orbit around Earth. The table shows the proportion of the moon that was visible from southern Ontario on days 1 to 774. So the first thing it asks us is to determine the equation of the sinusoidal function that models the proportion of visible moon in terms of time. So if you take a look at your chart that you have here, the best thing for us to do to be able to see this is to graph it out. So again, I'm going to go to Desmos, and I'm going to create a table of values so that I can graph it out and see what it's going to look like. So in my table of values, X is the day of the year, and Y is the proportion of moon visible. So the first day that we have is 1. The next day that we have is 4, right? Because I'm just using these numbers up here, then 7, then 10, okay? 1, 4, 7, 10, and so on and so forth. If only it was actually going up by increments of 3, then Desmos would auto-complete it for us. But unfortunately, it's not the same increments. And then we're going to do the same thing for our Y values. 70 and then 74. So then I'm going to go back through and I'm going to list all my Y values, and here the Y values are the proportion of the moon visible. So 0.02, 0.22, 0.55, 0.83, 1.73, so on and so forth. You guys don't need to watch me continue to type in these numbers, so I will be back in a second. Now, if you notice, our scale here is just not going to be helpful for us at all. So what I'm going to do is I'm going to change my settings, and we're looking at it from days 1 to 74. So for my x-axis, I'm just going to go from 0 to like 75. And then since we're looking at the proportion of visibility, the lowest visibility we could have is 0. There's no visibility. And the highest visibility we could have is 1, 100% visible. So we'll say from 0 to, I'll do like negative 0.1 to like 1.1, so that way we can see the x-axis. So right here, if you can tell right here, it definitely looks like it could be sinusoidal. And if I were to connect my dots, it definitely, again, looks like it's sinusoidal. It's not smooth because it's drawing straight lines from each point to each point, but it's definitely got that sinusoidal feel to it. The last thing I want to do is I just want to label this right here, day of the year, and then up here on the y-axis, we're going to label this proportion of moon visible. Okay, so this is what we're looking at right here. So the first thing we need to do is find an equation. Well, I need to find out what the minimum value is and the maximum value is. So it looks like the minimum is 0 and the maximum is going to be 1. Okay, we also need to know how long it takes to complete a full cycle, and it appears right here that it would take about 30 days to complete a full cycle. Okay, so right here we've got a full cycle done in about 30 days. So if you look right here, from 29 to 59 is 30 days. Okay, so let's get all the information down and go, and we'll use that to help us figure out our equation. Okay, so our max is 1, our min is 0, and our period is 30. Okay, if our period is 30, then our K value is going to be 360 divided by 30. So K is going to end up being 12. Okay, all right, so let's find the equation of our axis. So I'm going to take the max and the min and average them. So when I take the max and the min and I average them, I end up getting 1/2 or 0.5. Okay. To find the amplitude, I'm going to subtract the min from the max, and then divide that by 2. So the amplitude is also 1/2 or 0.5. Okay. We know the K value is 12. And the last thing I need to do is figure out, am I going to use sine or cosine, and then what the phase shift is going to be. So if you see right here, it appears to start at its minimum, increase to its maximum, and then go back to its minimum, which is the cosine graph, but reflected, which means that when I do my equation right here, the A value should end up really being negative 0.5 if I'm going to use cosine. And if I do it that way, then I wouldn't have any phase shifts at all, so D would be 0. So based on that, my equation should be y equals negative 0.5 times the cosine of 12x plus 0.5. And you know what, you guys, let's do this in function notation because I haven't done that in a while, and I want to make sure we're still okay with function notation. So we're going to say f of x equals negative 0.5 times the cosine of 12x plus 0.5. Now I'm going to go ahead and graph that on top of my chart that I have in Desmos. And I'm going to verify that this equation really is going to work. So I'm going to say f of x is equal to negative 0.5 times the cosine of 12x plus 0.5, and it appears to pretty much fall on top of the graph. Okay? But if you notice, it actually appears like I should have a phase shift because the minimum occurs at 29, but here in my graph, my minimum is actually occurring at 30. So if I were to say 12 times x minus 1, I think that that would give me a little bit, sorry, x plus 1, because I need to go to the left. I think that that would give me a little bit better graph right here. Okay, so let's just adjust that in our equation right here. We'll say f of x is equal to negative 0.5 times the cosine of x plus 1 plus 0.5. Okay, all right, part B, determine the domain and the range of the function. Well, remember our domain is our x values, and our x values are time, so we're talking about days of the year, so that means it has to be between 0 and 365. Our domain has to be x is an element of the reals such that it's between 0 and 365, and then our range is going to be f of x is an element of the reals, and our range represents the proportion of the moon visible, so it's going to be between 0% and 100%, so it's going to be between 0 and 1. Okay, and then lastly, use the equation to determine the proportion of the moon that is visible on day 110. So if my equation is f of x equals negative 0.5 times the cosine of 12 times x plus 1, plus 0.5, then I'm going to find f of 110 by doing negative 0.5 times the cosine of 12 times 110 plus 1 would be 111 plus 0.5. So then I would do f of 110 is equal to negative 0.5 times the cosine of, and I would multiply this 12 by 111, and I would get 1,332 plus 0.5, and then I'm going to plug that into my calculator. So to figure this out, I want to take the cosine of 1,332, multiply that by negative 0.5, okay, and then add 0.5, and it would be 0.65. So this would be equal to about 0.65. So therefore, about 65% of the moon will be visible on day 110. Okay, last thing I want to show you is you can go right into Desmos and check your answer by typing in f of 110, and we end up getting 0.65 as our answer. All right, that's it. Have a great day.